Hello everyone, welcome to another video by knowledgification. Today we'll be continuing our topic or language of chemistry. Today is part 2.
Today we'll be covering the following topics: chemical equation, laws of chemical equations, conditions required for a chemical reaction, balancing chemical equations, and types of chemical reactions. Let's jump in. By using various symbols and formulae, it is possible to represent a chemical change by the means of a chemical equation. So we can define a chemical equation as a way of representing a chemical reaction. Let's take an example. Let's say I mix calcium oxide with water. I will get calcium hydroxide. So this is an example of a chemical reaction that took place, and I can represent the chemical reaction in this way. So I'll write the formulas of the reactants which were involved, and I write the product on the other side of the arrow. So this is how I represent a chemical reaction by the means of a chemical equation. The substances which take part in the chemical change are called reactants. The reactants can be both elements or compounds or both. The substances which are formed after the reaction are called products. They can also be elements or compounds or both. Reactants are always on the left side of the arrow, and the products are always on the right side of the arrow. There are two main laws of chemical equations: law of chemical combination and balanced chemical equations. We will discuss them in detail. The law of chemical combination is divided into three parts: law of conservation of mass, law of definite proportions, and law of multiple proportions. Let's discuss them in detail. First, we will talk about law of conservation of mass. Law of conservation of mass is a law that states that mass can neither be created nor destroyed. This law is found applicable to all chemical reactions. This means that during a chemical reaction, no change in the mass of a substance can take place. The total mass of the reactants is always equal to the mass of the products. Law of definite proportions. This law states that when two or more elements combine, they combine in a fixed ratio of their weights irrespective of the method of preparation. For example, carbon dioxide can be obtained by three processes: by decomposition of metallic carbonates, by burning carbon, by reaction of the metallic carbonates with acids. When three samples of carbon dioxide produced by the three different methods are analyzed, the ratio by weight of carbon and oxygen has been found to be the same, that is 12:32 or 3:8. Law of multiple proportions. When two elements combine in different ratios to give more than one type of a product, the ratio of the masses of the element that combines with a fixed weight of the other element always bears a simple integral ratio. Example: nitrogen and oxygen combine and form compounds such as N2O or NO or NO2, etc. So that is a type of law of multiple proportions. If we analyze the ratio of oxygen that is combining with fixed mass of nitrogen in all three compounds, it bears a simple integral ratio, that is 1:2:4. A balanced chemical equation is the one in which the number of atoms of each element on the reactant side is equal to the atoms of each element on the product side present on the right side of the reaction. So let's take an example, and I'll explain it to you. Now, take a second's time and think, is this a balanced equation? Of course, no, because there are two atoms of oxygen on the reactant side and only one oxygen on the product side. So if we have to balance this equation, it would look something like this. Now the equation is balanced because there are two magnesium atoms on each side and two oxygen atoms on each side. This is a balanced equation. Soon we will know how to balance a chemical equation, but before that we will talk about the conditions required for a chemical reaction. Now let's talk about conditions required for a chemical reaction. There are 7 conditions required for a chemical reaction, and if any one of these are provided, the chemical reaction may take place. The 7 conditions are physical contact, solution, heat, light, electricity, sound, and pressure. Let's discuss them in detail. First, let's start with physical contact. Physical contact So a chemical reaction takes place only when the reactants are brought together in contact with each other. Let's take an example. When calcium oxide is mixed with water, we get calcium hydroxide, but calcium hydroxide is formed only when calcium oxide comes in contact with water. Otherwise, this reaction would not happen. Solution. Some chemical reactions take place only when the reactants are taken in form of solution. For example, AgNO3 plus NaCl results in AgCl plus NaNO3. So this reaction between silver nitrate and sodium chloride only happens when they are in liquid state or when they are dissolved in water, not when they are in solid state. Heat is also a condition required for a chemical reaction. A large number of chemical reactions take place by the absorption of heat. These reactions are called thermochemical reactions. For example, iron plus sulfur results in iron sulfide. So on simply mixing iron fillings with sulfur, there is no reaction taking place. But when they combine only on heating. So iron sulfide is formed only when iron and sulfur are heated together. Light. A certain number of reactions only take place when there's presence of light. They're called photochemical reactions. For example, photosynthesis. Photosynthesis does not take place in the absence of light. Sunlight is necessary for photosynthesis so plants can make food. Electricity. Certain reactions take place only through the passage of current. These reactions are called electrochemical reactions. For example, decomposition of water into hydrogen and oxygen. It's called electrolysis. So this process takes place only when electric current is passed through water. So as a result, we get hydrogen and oxygen. Sound energy. Now, some reactions take place by the absorption of sound energy. So for example, the decomposition of acetylene into carbon and hydrogen happens only through sound energy. Certain chemical reactions take place only when pressure is applied. So for example, the formation of ammonia from nitrogen and hydrogen takes place at high pressure in the bodies of animals. Before we start learning how to balance a chemical equation, we need to differentiate between skeletal equation and a balanced equation. Skeletal equation is an equation that is not balanced, and a balanced equation that is an equation that has equal number of reactants and equal number of products. Now let's learn how to balance a chemical equation. First, let's start with a skeletal equation. This is the skeletal equation we have. Iron oxide plus carbon results in iron plus carbon monoxide. Now let's learn how to balance a chemical equation. First, we check the number of reactants and the number of products. So we list them down on each side. Now we have listed the number of reactants and the number of products of each of them. So now we have to try to balance the number of atoms on the reactant side with the number of atoms on the product side. So let's take iron. Iron has 2 on the reactant side and 1 on the product side. So we have to change iron to 2 from the product side. So remember this one thing. Let's say that in the equation we have a compound, ferrous oxide. So if we put a number before it, the number will applicable to iron and oxygen. We cannot separate them and put a number in between them. This is a major rule we need to remember while balancing chemical equations. Now let's put a 2 before Fe in the product side. Then we will balance the iron on reactants and product side. Now we have balanced iron. All we have to do is balance carbon and oxygen. Let's do that now. So now our balanced chemical equation would look something like this. This is the equation we just balanced. Now I'll give you a question and now you try to solve it. I want you to solve this equation. If you have solved it, please put the answer in the comment section below. This is the answer to the question I just gave you. Now let's talk about types of chemical reactions. There are 4 types of chemical reactions: combination reactions, decomposition reaction, displacement reaction, and double displacement reaction. Let's talk about each of them. Combination reaction. A chemical reaction in which 2 or more substances combine to form a single new substance is called combination reaction. It's represented as A plus B results AB. A few examples are carbon plus oxygen results in carbon dioxide, or magnesium plus oxygen results in magnesium oxide. Decomposition reaction. The reaction in which a single compound splits into 2 or more simpler substances is known as decomposition reaction. The most common example for decomposition reaction is electrolysis, where we use electricity to decompose water into hydrogen and oxygen. Now let's talk about displacement reactions. In a displacement reaction, the more reactive element displaces the less reactive element from its compound. So it's represented as AB plus C results in CB plus A, where C is more reactive than A. For that, we need to know the metal reactivity series and halogen reactivity series. Displacement reaction depends on the relative reactivities of various metals. They are arranged in decreasing order of their reactivity. That is the metal reactivity series and halogen reactivity series. Now let's talk about double displacement or reactions. The chemical reaction in which 2 reactants or compounds combine to form new substances by exchanging their radicals is called double decomposition reaction. It is represented as AB plus CD results in AD plus CB. Here also we use the metal reactivity series and halogen reactivity series. And here also the most reactive element displaces the least reactive element. That's it for today. We have come to the end of our video. We have covered all the objectives of this video. Thank you, and I will see you in my next video.